All right, so we're gonna go, this is industrial project. This project, guys, is adopted by Michelle Cooley Erickson. They will be here tomorrow at 9 o'clock to introduce the project. So this is just to give you a quick update. I'm gonna start, this is on the network, guys. What I've done is I already set the project for you. So if you go to the team, I'm not gonna open it yet. Team one, who's team one? You guys are team one. The spring quarter is already set for you. If you go to the design drawing and Revit, and you already have a model of the industrial building central file set up for you. If anybody wants me to go over how to set a central file, I can do that with you guys. I would rather do it myself for you, just to make sure they're working right. But I can go through the exercise of setting up a central file. Already set central file for you and your partner. So everyone and every team should have Revit. It's a 25,000 square foot building, 2-story building, already set in Revit. Can I have thumbs up that we got that, Chad? Cool? Okay. So that's the first thing you need to know. And it's set up the same way that we did the commercial project, guys. You go to 6 quarter and you find all the information that you need about the project. Before I start, I'm going to go, if you go to the instructor folder, I give you guys 2 handouts. One, it says Industrial Project Development Schedule. This is the project, how we're going to do the project. The second one is the Syllabi. Both documents are online under in the instructor folder in the spring. So if you go instructor folder spring, if you go to, for example, ECDM, and if you go to, let's just, I'm going to go to this one, I believe. Let's go to the theory here. Lectures. Oops, I didn't put them on. I did not put the syllabi here. Interesting. I put the project. Okay, we'll take a second here to throw the syllabi in here. Give me 1 second electronically there so I can open it and you guys will have it available. So let's go to my documents, grab it from here, 6 quarter, in here, and let me go electrical department, academy. All right, 6 quarter, syllabi. Okay, so syllabi words 2012. Here you go. So this is the syllabi that you guys have, 2012. Okay, this is the first one. The second one is going to be right in here in a second, in less than a second. Let's go back here to calc, syllabi, and I'm going to go directly into this one here. Okay, so you have the syllabi and the schedules. So let me minimize this, go over here, syllabi, okay. So we are, if you guys, oh, this is not the one I want. Okay, let's go to the network so you can be all with me. There you go. Okay, so my interface with you guys will be through the instructor, like we did in the past. If you go under instructor, you're going to find the 3 quarters that you did with me. We are in the spring, so we're going to go to the spring. I'm going to start with syllabi with 231, and I'm going to start with the syllabi for 231. For 231, the syllabi for 231. All right. I should have put them. I usually concentrate on the project more often. Okay, syllabi 231. All right, so we can go right here and drag it in here. I usually don't do it. Okay. All right, done. Okay, so if you guys go ahead and look at the syllabi 231, the first, I'm going to go over the syllabis in a second here. Okay, your teacher is Chad. Will be with you for a month, for almost a year now. Here's the information, guys, about the start and the end of the quarter. The start is going to be the 13th, the 19th, and the end of the quarter will be, I believe it's going to be the end of the quarter will be June June 8th. June 8th is the graduation, end of the quarter. This project, guys, and I'm looking at the syllabi right here in front of you. Come on, bud. This is a syllabi right in front of you for the first quarter, 231. First class with me. This project, guys, is close to 25,000 square foot. We will design, this is just a description of the project that we're going to be doing. We will design power, lighting, and low voltage. Plus, we're going to do estimating, project management, a bunch of other things. So that's what this syllabi is. Any question, guys, about the description? It's an industrial project, 25,000. We're going to do lighting, power, and low voltage, plus estimating, and a couple of other calculations in the process. So that's the first syllabi. The textbooks that I have for you guys as a reference, we're going to have, you can see electrical exam prep, calculation, national electric code is required. You guys have that one. And the new book is electrical wiring industrial. And this will be our guide for the theory class, but also have some good information that you can use for the project. I want you guys to buy this one. Make sure it's edition 14th. We'll get into that one. We'll talk about microvolts estimation and electrical exam prep or electrical calculation. These are going to be the references for this. Softwares. So these are the books that we're going to be using. We're going to have a lot of softwares, guys, we're going to be using here. I can summarize. You know all the software that we did in the commercial, plus we're going to use Power Tools for Window. Power Tools for Window does short circuit analysis, harmonics, and so forth. So be aware of this. We're going to do the same thing with McCormick. We're going to do a bunch of other things in terms of softwares. Core abilities, that's why we have them. Competences, I always say, these are, I hope you don't ask me to read all these. I always tell you guys, these are what you're expected to know when you graduate from this quarter. For example, design lighting, power, and HVAC equipment circuits for industrial building. If you don't know how to do that after you graduate from here, you should ask your friend Chad for a refund, period. The way I look at the industry, guys, we throw a lot of stuff at you. We throw estimation, project, you name it. And if you can get 70% of every item that we throw at you, you have met the minimum standards for the industry, and you're good to go as a designer, estimator, project manager, as far as I'm concerned. If you get 70% of everything that we throw at you, that's good. So these are design security system, fire alarm, very similar, guys, to what we did in the commercial, except it's going to be an industrial building. What's the difference? We're going to have a manufacturing floor with bus ducts coming and feeding machines. That's the only difference, really, major difference between the two buildings that we did. The commercial project, we did not have a manufacturing floor. This, we will have a manufacturing floor. Okay, so you can lay out, you can look at all the layout. We're going to use Revit for this project. This is all the competencies, and I hope 36 of them. I hope you don't ask me to read all of them. I encourage you guys to look at all of them. If anybody asks you, what did you learn at Dunwoody in this course? These are the major items that you should have achieved by the end of the quarter. Can I have thumbs up, Chad? We know it, competencies. Okay, so you can read them at any time. Grading, you guys care about the grades more than you care about Chad. We're going to do, you can see what you're going to do. The most important thing I always tell the students is the design, all the design you guys do in Revit is equivalent to how much? Can somebody read that one for me? Nick? 30% of your grades, only 30% of your grades are on the Revit. Does that make sense? Even though we spend a lot of time on that, only 30% of your grades on Revit. The rest of them, assignment on time, 5%, cut sheets, 5%, estimation 10, generator sizing 5, lighting calculation 5, load calculation 10, energy code 5, power analysis, that's new. This is a new one. Power analysis 5, presentation 5, project binder 5, project specification schedule 5, and specification 5. It is unheard. You could get an A on the Revit and fail the class. Nobody fails my class, but you could easily get an A on the project, guys, on the Revit, all the design, and you still get a C or a D minus. I want you to understand that. So you were very good. You submitted almost everything I asked you for, guys. I can take the project that you gave me, give them to any professional, and you will get. In the industry, we get pass fail. You will pass. So it might not be perfect. There's nothing perfect in the world, as far as I'm concerned. There's always room for improvement. Any question, guys, about the grading? Any question? Can I have thumbs up? We know how the system is going to be graded. And the A's and the B's and all this good stuff assignment. Here's how the A and A minus and so forth are divided. You guys can look at these. By the way, all these are also set on the network for you. The classes are already set in the network. Respectful environment. Aladipo, I don't want you to kick me in the face like we did last quarter, so please stop that. Added drop. I doubt that any one of you guys will add or drop at this point. Technology statement. You have been good at using technology. Some of you use a lot of Facebook this time. Hopefully, we'll minimize the Facebook interface this time. My Dunwoody is my interface with you. You're going to find your grades and attendance on my Dunwoody, and you know that. Disability, other than Rob, I don't think we have anybody with any disabilities that we can tell. Oops. Progress, probation, nothing. Attendance policy, I will remind you guys, our attendance is 95%. And if you see other people don't have a 90%, they will get an incomplete. So don't sweat it too hard. Our attendance is to be here 90% of the time. Okay, so that's appropriate behavior. As I said, Aladibo, don't hit me in the face this time like you did last time. Okay. And that will leave us, guys, with the schedule. And I'm kidding here, just for the record. Aladibo has been a great guy. This is, guys, the most important thing. And why am I missing? This should be week 1. And this should be week 2, Chad. I don't know why it came week 1, 2, 3, 4, 5, 6. Okay, this is, guys, the assignment, the weekly assignment that we're going to be doing in this class. The weekly assignment, March 19th to 25th, set up the project. I want to go over this in a different scenario, guys. Handouts and so forth. This is equivalent, the same thing that you're looking at in the project schedule right here. The development schedule, exactly the same. But I have to put it in the Syllabi. So from 1 all the way to week 12, where we're going to graduate you. Any question about this? I'll go over this in details when we talk about the project. Can I have thumbs up? We know what this syllabi is going to be encountering. Okay, so that's my syllabi for the project or for the lab. Let's go to the theory right away and open the theory. By the way, you guys have them electronically, and you also have them right in front of you. Electronically, and you also have them right in front of you. Okay, let's go to the theory. The idea of the theory, guys, this book, Electrical Wiring Industrial, is to give you the code and the material identification and the code and the theory behind designing power system and lighting for a commercial building. That's the whole idea of this book or this class, is as we go through designing the project, we need code knowledge and theory. How would a hazardous location place wired? What's the difference between wiring a hazardous location place and wiring this room? The difference between manufacturing floor and any other room that we did. This book goes through hazardous location and also goes through manufacturing floor with bus ducts, plug-in bus ducts and feeders. Great, I think it's a great asset to add to you as you design the project. So that's what we're going to be using. So what's the goal of this class that we, other than charging you guys an arm and leg for it, right? You agree with that one? Is to give you the knowledge, the code knowledge, and the theory behind industrial project. What do you need to know to design an industrial project? So that's it. The textbook that we're going to be using, as I said, when the Electrical Wiring Industrial, the 14th edition, based on 2011 NDC code book. And what better than the Bible to use? Of course, we're going to be using the NDC code 2011. So that's your theory, typical. The prices might be a little bit higher than I thought here. Core abilities, this is just for your knowledge about why do we put these classes. Look at this. Communicate effectively using reading, writing, speaking, and listening skills. That's art and science on us. You guys have done a great job. A lot of you have done a great job in the presentation on that. Okay, if you ask me why do we charge you an arm and leg for this class, these are the competencies, aka the skills that you guys are supposed to learn. For example, explain service entrance conductors, feeders, and branch circuits for industrial buildings. What's the difference between a branch circuit in an industrial building, a commercial building, or residential building? The only difference is the wiring methods that you are allowed to use. So all this stuff we go through it, guys, in the NDC code book. Explain service entrance equipment, panel boards, PDUs, UPS, ATS, all these things, how it works, related to the code. All these competencies, aka skills, will be going through this code, this class. Explain security system for industrial building, fire alarm system for industrial building. That's what we're going to be going through. Explain harmonics for industrial building, hazardous location, analyze commercial building plans and specifications. And I'm just picking here and there 19 competencies, aka skills, that we think you guys should learn. Any comments about these? And I hope you don't ask me to read any or all of them. Any comments, any questions? Ashley, my friend, any comments about these? So this is kind of the contract, if so, between you and I. Here's how we're going to grade this one. Typical for Chad, you guys can be with me with 1 year. I don't change. I like the whole year to be smooth, transition from one quarter to another. I hope it was. Here's a class. We're going to have 4 tests. Last quarter, we were able to only do 3 tests because of a lack of commitment from your teacher, not from you guys. So 1 through 4, here's the test, a classroom engagement, homework, and final exam will be the same thing. The homework for this one, Tal, my friend, will continue to be you and your partner, 1 odd, 1 even. Continue to be 1 odd, 1 even. You submit your homework. We start on Monday. You submit your homework on next Monday, the due date for the homework. Cool? Start today. All week homework will be due next Monday. Any question, guys, about the homework for this one? How much it's going to cost? It's easy to get 10 points out of Chad. And yes, I do have the answers for these. And yes, I will put them on the network for you guys. And homework is an honor thing, guys. You do it for your own. I just give you credit. I read it's easy to pump your credit with it. You do them for your own. I hope you do them, though. Classroom engagement is a great when you guys when we have speakers and so forth, you get 10 out of 10 in the classroom engagement if you are engaged with the guests and myself. This is how the grading is going to go, guys. The A's and the B's and the C's and the F's. I don't give F's. The same thing, respectful behavior, blah, blah, blah. All this, guys, is identical. And classroom, I do classroom engagement all the time. I put 10 things. If anybody is to come and say, Chad, why did you give me 7 or 8 out of 10 in a classroom engagement? Here's the 10 things that I look at, guys, I keep in my mind when I give you, or I justify it, to justify giving you the grade. Cooperating with and helping other students, participate in classroom discussions with visiting speakers, students, and instructors, and so forth. And these are typical. We did them in the fall, in the winter, and we will do them in the spring. Neat, clean, and organized desk and basket. You can see I went through all your baskets, guys. I hope I didn't throw anything private for you. I tried to do my best on that. I hope it will stay like this, especially with the guests and the speakers. Okay, the most important thing in this syllabi, Nick, is the schedule. The schedule. This is how we're going to run the class. And I know Chris is going to go put them all in one, and we'll put them on the wall like we did last time, if you want to. Here's how we're going to do week 1. Week 1, we're supposed to do chapter 1 and chapter 2 in here. Chapter 1 and chapter 2, guys, in here, in this book. And this book has, I think, 20. It has 20 chapters, only 20 chapters. We're going to go over each and every one of them. Each one of them has a theme, like harmonic, hazardous location, feeder busway. These are all typically found in industrial. So they really have a theme for them. So we're going to go over we're going to average 2 chapters a week for 20 chapters until we go all the way. The tests and the test dates and the weeks are here. We might have to shift sometimes, just readjust, but the plan is there. When are we going to have the test? For example, test 3 is going to be 11 through 15. It's going to be in week 9 to give you an idea where things are going to be located. Does this help you guys plan your stuff like we did in the past? Okay, so that's I like the schedule because hopefully, and for the most part, Chris, we were able to kind of stick to the gun for the most part. We got on enough, but for the most part, we were able to follow the plan. Any question about the schedule for this class? Any question about the schedule for this class? What's the textbook for this class right here? You guys can buy it. Okay, so that's this book. Let's go to the last class you're going to do with your friend Chad. The last class is the theory. Same information. Here's the syllabi. You guys have all these syllabi for you. In this class, whom am I going to pick on? Oladipo and Dustin. This class, guys, is the theme of this class is calculation. We're going to do a lot of calculation related to industrial project. For example, sizing bus ducts, sizing MCCs, sizing MCCs, motor control centers. We're going to size bus duct, plug-in bus ducts. We're going to size PDUs, power distribution unit. We're going to size UPS system. These are all we haven't done it in the past. We're going to do it in the industrial. Plus, we're going to be sizing switch gears, switchboards. We're going to talk about grounding and bonding in details now. Grounding for one building, grounding for separate building, how to ground the building to another building, separately derived system. So we have detailed stuff about grounding and bonding. So that's really You're going to enjoy it. I hope you're going to enjoy it. I don't have a textbook for it. I used to have a textbook. Um, so what I do, guys, I have a presentation for you. When if we're going to be talking about grounding and bonding, I'll go my lecture about grounding and bonding, meaning calculation, grounding and bonding. Then I will assign a homework for you on the spot. I have homework. I say, here's what we did today, and I would like you to change this calculation to make the switchgear, for example, 2,000 amp switchgear instead of 4,000, and do the calculation. And instead, we will do an example for 4,000 amp switchgear grounding, okay? And then at the end of the lecture, I will change it into 2,000 and say, please do this as a homework. Do the calculation as a homework. That's how I do the calculation. So you're going to enjoy a lot of calculation. As I said, I have the electrical estimating book, but we really, other than doing the estimating using McCormick or Accubit this year, we don't do a whole lot with it. National Electric Code is always our Bible for this. The competencies, here's everything is about calculating. Calculating for sizing lighting system for industrial building, branch circuit in industrial building. Can I use a 30 amp versus 20 amp? Can I use a bus duct to feed lights? Yes. So we talk a lot, guys, about lighting, receptacles, bus ducts, UPS, PDUs, ATS, MCCs. These are all associated with industrial building. Plus services. How do you do a service? Always service and feeders and branch circuit in an industrial building. Any comment, any questions about this? If I were you guys, I will take these 16, and these are basically what you should get out of this class to justify the amount of time and money that you paid out of it, basically. Any comments about these? So if anybody, Dustin, my friend, asks you what wiring methods preferred in an industrial plant, you should come up with 2-3 ways of wiring in an industrial environment. You're going to ask, is it hazardous location? Is it class 1, 2, or 3? Do I need seal? Do I need explosion-proof equipment? Do I need a bus duct? What's the best way of wiring a manufacturing floor? Should I use a bus duct? Yep, a great way of doing manufacturing floor is a bus duct. What is a bus duct? What's a feeder bus duct? What's a plug bus duct? All this stuff, we're going to do it right in here. The system that we're using for this project, guys, is 48277. So you get involved in so-called separately derived system. You take a 48277 system and you feed a transformer 28120 to feed your receptacles. So how the transformer that I own and operate is going to interface with my service that's 48277. So it's really cool. I think it's cool. Any question about the competencies? Any question, Jackson, my friend, about the competencies that you do? Okay, grading is identical. I do my grades identical. You can see for test, classroom engagement, homework, final. Final is only 30%. The grade scale is the same. Everything is the same. Classroom engagement. The more you engage, guys, when I look at you and you're with me, that's great. So you get the 10 point out of 10. But I think you're not here for the grades. You're really here for the skills mostly, and then the grades come second. Or is it first, the grades and then the skills? Or side by side, 50-50? Okay, the schedule is the single most important thing, guys. Week 1 all the way to week 12, this schedule is very important because you don't have a book. So for example, in week 1, we're going to do introduction, then we're going to do article 430 motors, 445 generators, and 368 busways. This is the theme of the quarter. So meaning you will have a calculation of at least 1 or 2 calculations about each one of them. Does that make sense? So these are, I put the articles here that will be, then we have capacitors, we have panels, we're going to talk about transformers, HVAC system, PDUs, UPSs, you name it. So these are all the topics that we're going to be doing calculation about. All the way to, some topics are repeated, Chris. So there are certain topics like 430 repeated multiple places, just because we look at it from a different angle with a machine or something like this. You're going to enjoy it. Any comments, guys, about the schedule? Where the tests are going to be also are here. For example, test 4 is the theme of test 4 is going to be 430 motors, MCC, 445 generators, 368, and 695. 695 is fire pumps. These are the fire pumps. So we'll talk about fire pumps too, how to size fire pumps, what do they work, jockey pumps, interface with the controller, and so forth.
You have homework number 7. That's just homework for week 7. Or what is that, a chapter? What's that referring to?
Uh,
HW.
yeah, homework number 7. It really refers to what I'm going to assign to you that day. No chapter. It doesn't go with the chapter.
Oh, okay, so it's, yeah,
Thank you.
it's no text reference.
There is no text. Thank you. Thank you. Very good point. The homework, guys, that we have over here, if I can, the homework that says 7, and these are assigned on the spot homeworks for you. Homework number 6 here. These are the assignment that will assign for you after here's what I do this. After we finish the calculation, if we're doing UPS, we finish the UPS. For example, we're going to size a UPS that's going to end up with 5,000, or let's just say 1,000 kVA. I will put 500 kVA and I say size now for 500 kVA, and that will be your homework. So I will assign it after the lecture immediately. No textbook. Thank you. Any question, guys, about this? Good point, though. Any question about the syllabi? Okay, all these syllabi are online. You guys have a copy of it right in front of you here, right? Everybody got a copy of it? Great. Let's switch into the project. If you guys go to the project, let's go back. My interface with you, Ashley, is through the network. Everything that I do is going to be on the network. So this is the instructor folder. Each one of you is going to have a team. Each two of you are going to have their own team. You guys know which team. I have my own team as an instructor. So I'm going to go to the instructor here. I'm going to go to Spring, and I'm going to go to the project 230, and I'm going to go to the work schedule, work scope, and the work scope. Work scope is what you're looking at right here. That's right in front of you. Okay, I gave you a hard copy, and if you lost your hard copy, what do? Can I get this one on record recorded? If you guys lost your hard copy, what do? They're right in here. I just assemble them in a better way in a hard copy to make sure that sequentially how it's going to go. Okay, so let's go to the first page is industrial project schedule development, right here. So this is the first page that you're looking at. It says industrial project development schedule 2012. Okay, I'm going to allow Mishad, guys, tomorrow to go through them in details. But here's what we're going to do. We have week by week. The most important thing is the week. What's the outcome of the week? Like this week, we're going to do Revit setup, E1 through E14, and we're going to do load calculation and project schedule. Done. This is the outcome of this week. So if you guys are a new partner, one of you will be doing, later on, I'm going to start you guys with the setup, Revit setup. And then I have a calculation, load calculation, and a project schedule. You're going to, for the project schedule this week, here's what I suggest you do. Can I guys give you, for the project schedule, take the commercial project that you did, copy it, name it industrial project, and put all this information in it. That's the easiest way, and you have it printed. Remember, you have it, guys, in a Word document, so you can copy and paste in Microsoft Project. Can I get you guys? Can you give me a thumbs up that Microsoft Project will be easy? The first thing you need to do: go copy the commercial, name it industrial, change the name, change everything, change the start date and everything to reflect the start of this. Grab the schedule that you're looking at right here and copy these milestones and tasks into the project schedule. Can I have thumbs up for the project schedule? We're cool? Good? Okay. The second thing, guys, is called load calculation. Load calculation that you need to do this week. Load calculation, you have two options for load calculation. You either copy, again, don't start from scratch. Copy the commercial project because there's a lot of things repeat itself, and put it in the industrial and start your calculation. And to make it easier for you guys, what I did, because I know if you go back and you go to load calculation, oops, if you go back and you go to load calculation, let me go grab it. It's not there yet. All right, so let me go here. It takes me a second. Load calculation. Let me go grab the sample of load calculation that we did and put it for you right here. This is a sample of load calculation that we did before. We don't want to reinvent the wheel, so I'll just go grab it and tell you how it's going to be organized and so forth. Let's go back, and here is the instructor folder all the way into load calculation. Here's what I have, a PDF file of the load calculation, and I'm not going to go over it at this moment, but let me just show you a quick layout. And again, by any means, I know, Chris, you like to do yours in a different way. By any means, you don't have to do it the way I did it. But this is a PDF file of how I expect you guys. The numbers in it are not accurate. Can I get you guys to understand the numbers in it are not accurate? So don't use them. You can use them if you don't understand, if you don't have the information yet, you can use these numbers, but they're not accurate. So you start with the calculation here for the service, and then you need to find the following. If you go, here you go. So if you can go, here's a calculation for the service, and you come over here, you're going to calculate the switch gear, receptacle panel, lighting panel. We have mechanical panel 1, mechanical panel 2, 480 busway, 208 busway, UPS, PDU, EP, emergency panel. So these are all the calculations that you need to do. So your choice, Chris, I know you do it differently, your choice. What I asked the students in the past is when you do the calculation, you grab like under PDU, here's the load that's going to be under PDU, expected loads. And you can go all the way down, and then this is where you can size each one of these from one calculation. Look at it. I know I don't want to make it load calculation, but here's all the most important things is the steps. You look at these steps are accurate steps. You guys are going to build it, make sure you reflect it in your load calculation. And as you calculate, you're going to pull the information to this cell under the switch gear is the main service. You're going to go all the way pulling the information under the switch gear. You're going to size your switch gear at the end. 4,000 amp switch gear we have. And then you're going to pull some info on the receptacle panel. What do you think is going to be on the receptacle panel? Receptacles, receptacle loads. So you're going to pull the receptacle on the receptacle panel so you can come up with load, a panel size. And the same thing for lighting panel and mechanical panel 1, mechanical panel 2, and so forth.
The bus trucks, are they separate panels, or what are you referring to?
A bus duct is, a bus duct is basically a big bus, copper bus coming out of the switch gear, and the load, it's like a panel, but it's really not a panel. It's a distributed load panel. So if instead of bringing say if I have, you guys are 10, say if I have 10 machines right here and I want to wire them, 2 options. I can wire them with a feeder from this panel, 1, 2 feeder for each one of them, 10 feeders, option 1. Option 2 is a bus duct. You grab one big fat bus duct with copper, you pass it right at the top of you guys here, and you take an ASO cord and you tie it to every single machine. That bus duct need to be sized. Is it 200 amp bus duct, 400 amp bus duct? That's what I mean by the bus duct. So how are you going to size it then? You're going to size it based on the load that's tied to it, the loads that tie to it.
And where are the loads in this file, or are they somewhere else?
I'm going to show you. All the loads are here.
Are in this
Yep. All the loads. No, yeah, they are actually in these PDF file. The loads, for example, here's all the loads. Can you see that? Here's all the loads that you can have here, and we have them in a different format too.
Right.
Yep.
So anyway, we're not getting those from the way we got them last, from us customers.
They are also there, but they're into this. Here's all the mechanical loads, for example, right in here. All your mechanical loads are in here. So I thought to make it easier for you guys to put that format at least. And again, I know, Chris, you like to do it differently. Do it any way, shape, or form you want. But this is at least my expectation when you guys are done. One file or multiple files to tie and do the calculation for all these. Any question, guys? Okay, so this is already on the network for you, so you can start today working on it. Let's go back into my load calculation, my project schedule. Okay, here you go. So can you give me a thumbs up, say, Chad, we have a sample of the load calculation and we know how to grab it at least as a start point. Can I have Tal, my friend? Good. Jackson, as a start. Okay. Can you guys tell me the project schedule? No, we know what we need to do for the project schedule. What do we need to do for a project schedule? Copy the commercial project to industrial, rename it, reset the start date, and input all this data into it. The schedule data. Can I have thumbs up that we know how to do that? This is our assignment for this week. Okay, Revit setup. Revit setup, guys, after lunch, what I'm going to do is going to remind you one time how to do Revit setup after lunch. We will walk you step by step how to do Revit setup. I know we did it in the commercial project. We'll do it one more time. And when we say Revit setup, guys, you're going to set the sheets. I'll show you how to set the sheets, the name and the title and everything else, and bring the views, Ashley, and put the view in the sheet like we've done. And that's it. That's the outcome for this week. We're not, if you are ahead, you can start next week, Floor. But if you're not, I'm satisfied with on Friday, have everything, guys, set up for you. If you have everything set up, that's good outcome for this week. Okay? Can you guys just give me a thumbs up? We know what to do with this week at least. Okay? Because that's the start. Okay, next week, we're going to have low voltage, a clock paging security fire alarm system, E9. By the way, you guys are familiar with E1 through E14. There's 14 sheets we're going to set up. Then we're going to start in each sheet. I'm going to let Mashad Cooley guys talk about all these in details. They like to talk about these. We have speakers and we have field trips and speakers. So all these field trips and speakers are here. I'm going to allow Mashad tomorrow to go over this. They like to do it. So, but for the time being, you can see, guys, Mashad is going to be every Thursday. Can you guys see? Every Thursday, Mashad will be here, Mashad Cooley Erickson. This project is their project. It's adopted by them. They were generous enough to give it to us years ago. We redeveloped it in Revit and we're using it. It's greatly supported. We can go to Boston Scientific, guys, and visit a similar project to a building that's similar to the project that you're doing. That's really nice. Bus ducts and so forth. That's really cool. There's a lot of cool stuff here. Highlight of the game is a visit to Cummins power plant in Fridley right here, where we tour the plants and they do switch gear pedaling right in front of you. And this is the highlight, and they give you guys a lunch, and we spend 4 hours there. I think that was the highlight of the project. Any question, guys, about this? I know I'm going to allow Mishad to talk a little bit about these. Can I have thumbs up for this schedule? At least we know what the schedule is. Okay, the only thing that my concern is week one, we know we're going to do, I'm going to help you set up the Revit after lunch, and we do load calculation project scheduling. We know how to start this. Okay? All right, so this is document one, and that will make the first 2 pages of your, the stuff that I gave you guys, the first 2 pages, the first page, front and back. Okay, so if you go to the second one, let's go back into my schedule. The second one is what I call it design development requirement right here. You guys are looking at it. Everybody's looking at that document here. This is my document or our document. This is all the industrial project consists of the following. You're going to do a project schedule, Microsoft, load calculation, Excel, design, Revit, Minnesota Energy Code ComCheck, lighting calculation, visual, power analysis, PTW, generator sizing, Cummins, specification, Microsoft, cut sheets, estimating using McCormick, or I have McCormick here, but we will be introducing Accurate too. And project presentation like you guys did, and so forth. So that's the requirement that you need to keep in mind. Requirements is we're going to have a scope provided by Mishad Cooley Erickson, and I will give you things as needed. Project schedule on Microsoft. Here's you guys are going to design this. Here's the teams of the people who are going to be working on this project. We have 3 electricians and 6 apprentices when you do the estimation. So please pay attention to that one right here. Then the most important thing that you guys are going to be doing today is this. Set up sheet 1 through sheet 14. These are the sheets that we're going to set them up. Title sheet, symbols, one-line diagrams, blah, blah, blah. And you go through all these. The bolded one, the bolded stuff, Chris, see the thing in bold is what the name is going to be. The one that's not bolded is just description. For example, it's going to be second floor plan low voltage system. I don't want you to write in Revit all this stuff. This is just for the bolded stuff is what's going to be the title for these sheets. Can I have thumbs up, guys, that we understand this is what we're going to be doing in Revit? Setting up all these E1, 3, E4, which you guys have done it with me now in CAD, and we didn't done it in Revit. For commercial, we're going to do it for the industrial. So E1, 3, E14. Remember, there's E1, one-line diagram on riser. We're going to do that. Okay, Revit drawing setup. You guys are going to do it after lunch with your friend Chad. We will be doing that one. Families. The families for this project, guys, it's given to you on the instructor folder. We used them, the same families that we use for the commercial project. So Minnesota Energy Code, we're going to do the calculation. I want to bring to your attention, Tom, my friend, when you guys look at Minnesota Electrical Minnesota Energy Code calculation, UCC item number 14. So please refer to this. It refers you to what's the expectation from this. I made it easier for you this time. So if you go all the way to the end, item number 14, it will tell you what you need to do for the energy code. Service calculation, see item number 14. So you're going to go to also item number 14 for that one. Load calculation. Cut sheets, cost estimates, project presentation, project submittal, the end of the week. Here's what your project binder is going to look like. And oh, by the way, I have 2 projects already done, right, sitting here for you as a sample. We don't reinvent the wheel. The wheel has been invented. What I want you guys to, here's a sample. Do better than that. This is the project in 2 binders, 1 project in 2 binders. And this is another sample of 1 project in 1 binder. So here's 2 samples right here. They're going to sit right here, guys, all quarter for you. You're confused with something, feel free, you're not cheating, feel free to come over here and see how we have done it in a different project, especially from now around. Cool? Can I have thumbs up, Chad? We know that these are available for us as a reference, right? How, my friend, Dustin? Okay, so they're going to be sitting here all quarter for you. Okay, so how the project is going to be, the binder, exactly what we did, like we did the commercial project, guys. We're going to start with the project narrative, project schedule, all the Revit drawing, electrical calculation, lighting calculation, Minnesota Energy Code, generator, power analysis, project estimated specification, cut sheets, and PowerPoint presentation. Exactly the same like we did. The only thing I took away, anybody notice what I took away here? Look at 12. What was after 12 last quarter? Was reflective statement, right? Reflective statement is optional. Cool? Because I kept reading your reflective statement, guys, and I sounds like my language for a while. Sounds like that's what I did. That's what I wrote. So it's supposed to be your own lingo with what you like feedback. So if you write a reflective statement, great. These are what the project is really. The items, what the project is going to be. Okay. Here's where project binder tabs. What I did this time so it doesn't confuse you. Is it wrong with Excel here? Okay. What I did, guys, so it doesn't confuse you here. For project binder tabs, details, the tabs details, I have load calculation. Here's all the load calculation I would like you to do. And oh, by the way, if you go to the load calculation sample that I gave you as a PDF, it reflects this, okay? Energy code, if you go to energy code, it will tell you what the energy code in and outside, inside and outside, cool? If you go to the power system analysis, here's what we're gonna do with the power system analysis. If you go to generator sizing, here's what we're gonna do with gen sizing. Estimating, the same thing. Cut sheets. Ashley, like we did last time, please look at the cut sheets that I'm asking for. I'm asking for this particular cut sheet. So don't go, guys, do cut sheets different than these. I want only 10 cut sheet things. So everybody can see what the cut sheets are. Do you see any conduits, any receptacles? Nothing. All panels. Cut sheets. Visual. You guys are going to do visual. We have 2-story buildings. So we're going to do the same thing, the top and the bottom calculation for visual. And here's the 9 things I want you to do and print in visual. And the last thing is the end will be the end of the quarter. Any question, guys, about that? So I hope I think we have a good plan, right? Everything's laid out for you. So all what it takes is just get it and get it done. We're going to have a fun quarter, guys, I believe. It's going to be really fun. Any question about this? Any question about this? Okay, so that's that's basically what the requirement. Everything that you're looking at is right in front of you or online. So if you forgot it, it's going to be online in a PDF. Okay, what I'm going to do, guys, I'm going to give you a 5 minutes break, and then I'm going to scan right through the spec, the specification that came from Shad Cooley Erickson of how are we going to design this project. And they're going to go through it in details. And then after that, we're going to start Revit setup on the spot. We're going to start setting up Revit. Okay, thank you. Okay. So, if I can have your attention, guys, for a second. This will be your industrial project. I will do the setup in a second in Revit. 3D 2-story buildings, 1 manufacturing floor. So that's the view that we're going to be looking at and setting up in a second here. So if you go over here, you're going to find the first floor, manufacturing floor right here. As you can see, we're going to have offices here. We're going to have a data center in this area here, mechanical room, and all this good stuff, generator room and so forth right in here. The second floor, it's going to be, this will be a lab, I believe, an open area here. Lab and an open area for like the lunch room and so forth, and still the open offices goes all the way up to the second floor. But the main thing right here is a lab in the whole area here, as well as the rest area. And I'll show you that one in a different format. So just give you an idea. We'll get into the setup in a second here, but let me go into the description. So I walked you guys through two things. I walked you through the industrial project development schedule and the design project. We're going to go next into the scope. So if you guys go to, let's say, scope of electrical system, medical, production, manufacturing plant, everybody can see that? Can you guys see that? This is what we're going to go through. You have a hard copy and a soft copy of it. Okay, so long story short, the most important thing really about this project is two things. You're going to have two floors. One of them is 10,000, 5,000, 15,000. The other one is 8,000. So this is the most important thing. It's a 2-story building, 15,000.8, almost 16,000 the first floor. The second floor is 8,000 that we need to design for. What do we need to design for? We need to design for power, lighting, and low voltage. That's it. Assumption, I'll let Mishad Cooley talk about this one, guys. All the code requirement that you have to adhere to. And by the way, this is Mishad's spec, so it's a really real engineering spec. That's exactly what you expected to see. What we call this, guys, when we meet with the customers, this is kind of the understanding what we are supposed to do for this project. So here's the work included and assumptions. It says the telephone is going to be provided by the owner and so forth. Typical, guys, but to get you into the exercise, we always do the phones. So we're going to do everything. Here's the code that you need to adhere to, from the building code into the NDC code book and so forth. Design criteria 1.4, it talks about service calculation. Our service is a 48277 3-phase 4-wire system. We're going to do a switch gear, and from this switch gear, here's what we're going to be feeding, guys. We're going to be feeding our lights. By the way, our lights in this project are going to be burning at 277 volt. 277 volt. We have a transformer to feed the receptacle. We have another transformer for the manufacturing that runs at 208. We have a chiller that we need to feed from the switch gear. We have another manufacturing bus that runs at different voltage for 8277. And we have a mechanical equipment distribution panels, and we have closed transition system. This describes how the power is going to be put together. Okay. And I'm running through this because Mishad will talk about it in a little bit more detail. Design criteria, energy, emergency power. We're going to have a backup generator for the whole building. Backup generator for the whole building. Moving into the power criteria. If you guys look at 1.6, it will tell you what receptacle. Where do I need receptacles in this building? This is engineering understanding specification. Otherwise, how would I know where to put a receptacle in a commercial building? There's nothing in the NEC code book that tells you how many receptacles you need to do in a commercial industrial building. Nothing. So these are what give you the understanding where the receptacle is going to be located. Okay, we have design criteria, power distribution, what's going to be fit from each one of these power distribution. We have UPS, PDUs. Mishad will talk about it tomorrow. Design criteria for owner equipment. We have owner equipment that we're going to be feeding. Design criteria for mechanical equipment. Lighting. Here's the light. What I usually do with lights, guys, I will give you, when we reach lights, I will give you the spec, like I have done for other projects, the Lithonia spec page of every fixture that you need to use here. Make it easier so you can pick which fixture, like it's industrial fluorescent. I can give you the not catalog number, but a spec, which type of fixture based on Lithonia that you need to use. Okay. Typical, it starts with the illumination foot candle, the type of the fixture, and how do we need to control it. I want to remind you, Phil, that this building does not have a control a lighting control system. We do not have a lighting control system in this building, meaning we don't have a lighting control panel. It's you can have occupancy sensor. If you don't have a lighting control panel, how would you have an occupancy sensor? It's running through a power pack, just standalone relay in the ceiling. But there is no full spiel lighting control panel like we have done in other projects. If you want to do it, but not required.
So the high voltage controls?
They're all high voltage controls or occupancy sensor. When you see an occupancy sensor, guys, it's just an occupancy sensor here that drives a relay above the ceiling. You bring the power to it, to the relay, to the occupancy sensor, and locally. It's a local control. There's no control panel. Can I get you guys to have thumbs up, no lighting control panel? Because I'm sure you're looking at, and the fixtures are running at 277 volt. They're not 120 fixtures, they're at 277 volt. Lighting, we have lightning protection here. Lightning protection will go through lightning on the roof. Paging system, clock system, fire alarm system, all the description of all the stuff that we're going to have. Technology raceways. And that's the end of it in terms of Mishad's spec. And I'm not going to go through it because I want Mishad to look at it. Any comments, guys, about? So when we go for power, please refer to the spec that we got from Mishad. The second thing I want to go over, guys, is security system. The last page, if you go all the way to Mishad, after that, you're going to find something called this one. Can you guys see that one in your package too? I put them all packaged together. The scope of electrical system for security system. And it says also for fire alarm. I copied this one, guys, from the commercial project because Mishad's spec doesn't say anything about security system, and I would like you guys to get involved in security too for this building. So I put the security system here, as well as a little bit more of fire alarm system. So keep this in mind as we go through the security. Cool? Can I have thumbs up? The details is coming, guys. Okay. So back the last page. Are you looking at this page that looks something like this here? Okay. If this one is right here, Chris, if you click on the Excel sheet that you have, this is your mechanical equipment. Okay. You can't design a building unless you have a mechanical equipment in the building, right? It's okay. All right. So if you guys go, let me just see if I can minimize it. All right. Here's the stuff that you're looking at right here. This page is in the schedule. I'm just going to go zoom out here a little bit so we can see and start right here. So here's the air handling unit, R1, the right, and R2 and R3. We have 3 air handling units, guys. And we have an air handling unit pump right and left on the air handling unit. And the description of the air handling unit R1 is 25, 3-phase, 480. It's division, we still say division 15. I should change this one. The mechanical guy is going to do the control. And the starter is going to be, what type of starter are we using in that? VFD. Does that make sense? That's the most important thing when you read through this, guys, is to identify first the horsepowers, the voltage of the equipment, and the starter. Okay, what does full voltage non-reversible, what does FVNR refer to? You guys remember that from the mechanical schedule? Full voltage non-reversible. That's a NEMA. Like these NEMAs on the wall, contactor. Full voltage non-reversible. Okay, goes all the way, guys, into the voltage. Look at this boiler. This is just a control circuit for the boiler. Chiller. My chiller is 525 kVA, and that's not a mistake. 525 kVA, big boy. We're going to size it. Computer room cooling units, the crack units, exhaust fans, chilled water pump, and so forth. Environmental chambers at the end. We'll talk about this as we reach them. They're 52K each. And we have unit heaters. All your mechanical equipment, for the most part, are right in here. These are HVAC equipment, heating, ventilation, air conditioning equipment. HVAC equipment, heating, ventilation, HVAC, and heating, ventilation, and air conditioning. Cool. Any questions about this? This is this page that you have in your schedule. If you go to the last page.
Oh, do we know what mechanical panel they go to?
Anything, yes. Anything in the first floor will go to the first floor. Anything in the second floor or the roof will go to the second floor. So there will be two mechanical panels, one in the first floor and one in the second floor.
How do we know what floor they're on?
By the sheet, if you look at the load, I'll show you in the load calculation, we have them in red. I believe the ones that's going on the roof in the second are red in the calculation zone. I'll show you that when we reach it. Okay, can you guys look at this schedule here, the last page? Now remember, this is a manufacturing floor, so we are doing process. We're manufacturing product. So the manufacturing product, because we're manufacturing product, we need equipment, manufacturing equipment. That's what they call them, owner equipment list. That's the actual manufacturing equipment that we're going to have. So here's where you find this. You guys there are tabs in Excel. Go to tab 2. Everybody can see that, guys? Go to tab 2. Tab 2, here's where you're going to find all these mechanical equipment. This is how we read this. Okay? If you guys look at the first one is tube mill. I have the first fixture is tube mill, and I have 12 of them. They are 28120, meaning they need a neutral, and they are 3-phase, and the full load, this is full load amp for each machine is 13. Everybody knows how to read this schedule? These are owner mechanical manufacturing equipment. So let's go all the way to the grinder. The grinder is going to be number 11. Grinder, I have one of them. It's 480. It's 3-phase, and it's running. I have the amp is 7 amps. Cool? Everybody knows how to read these. So if you're looking at them, can you guys see that there are 2 voltage levels that I'm burning these equipment at? Which means as we design the bus duct, there will be 2 bus ducts. One for the 208 and one the 480, right? That's why we have 2 bus ducts, because we have 2 sets of machines. The most important thing, guys, is right in here. These numbers, I would like you guys to look at these numbers. These are correlated to the actual floor plan. So every time I'm going to show you, so 1 through 16, if you see in the floor plan, number 1, this means machine number 1 is going to be located wherever you see number 1 here. It's going to be machine number 1, and here's a description for it. Having said that, let me just quick see if we can get them in Revit, but we can also fire them. We can import them to Revit, or we can go directly into here, and that will bring me to your schedule, guys. Okay, AutoCAD. I have all the AutoCAD stuff for this project. Let's go back to here. Okay, so Spring Project. If you go to the project, you're going to have something called AutoCAD. Here's AutoCAD. I have the CAD schedule for you. If I go to the first floor, I'm going to open CAD. So you have 2 sets of drawing. You have CAD and you have Revit. We're going to work with Revit. CAD is going to be only for reference. Only for reference for you. So CAD is going to be only for reference. Okay, so while it's opening CAD, guys, just to show you how this is related to the drawing that we do. Okay, Excel. There you go. Okay, so these are, any question about these owner equipment or manufacturing process equipment? It needs to be sized. We need, these are, Chris, that we size SO cords for them. They're cord connected. The bus duct will be moving in here. SO cord with a fuse disconnect at the top, and we tie to the machine. Tie to the machine as we keep moving. Okay. Let me just open CAD to show you. Yes, sir.
We don't need to provide any cut sheets for those.
No, thank you. The only cut sheet that you need to provide are the ones are listed. Thank you. These are owner equipment. Guess who will provide the cut sheets for them? The manufacturing engineers, process engineers. That's it, baby. All what we care about is what's the amp and what's the voltage, and they're all continuous load. So when we size the disconnect and when we size the overcome protection device, you assume continuous load 1.25 for the amps, and done an SO cord. I'll show you how to size an SO cord for them, as well as disconnect and a fuse. Very good point. I don't know. I should know, but I don't know. It's a cord. It's here. This is an SO cord right here. If I remember that. I don't know what it stands for though. Yeah. It's SOOW. This is an SOOW cord. It's a cord, it's not a wiring method. Usually tie it to equipment, light, and so forth. Google it. Okay, I'm waiting for CAD guys to fire so I can show you the stuff. Okay, here you go. If you guys look, everything here in CAD, I want to remind you as you work with Revit, please have, all of you guys have access to all these CADs in your team folder. In your team folder, you have access to all these CADs. So if you want to import them to Revit so you can see them, feel free like we did in the past, import them to Revit so you can see them. Let me see if it fires here. So many things going on. Computers are way too slow for me. Bunch of things, you know. Close that one. There you go. So if you go to the model space, guys, I hope you didn't forget how to deal with the. Okay. Okay, cancel. All right, time right here. Close this one. Come on, buddy. Close this one. Okay, here you go. I want you, Chris, can you see the numbers here? Can you guys, I don't know if you, oops, it's hard for you guys. Can you see the numbers right in here? Number one. Okay. Okay, I find a better idea here. How about here? Can you see the numbers? Okay, so when you see number one, what does number one mean? Machine one. So machine one, machine one, machine one, machine six is here, machine two. This is not number of machines. This is machine number one. Cool? Can I get you? Because that's the most confusing one for the students over the years. All these machines, okay? So here's the manufacturing floor. So when you bring the bus duct, when we bring the bus duct later on, guys, right at the top of it, right here, see, right in here, and we're going to be feeding these machines depending upon the voltage from all these, right? So bring, tab it, and come over here. And remember, there will be two bus ducts. Why two bus ducts? Because you have two voltages. So here's two bus ducts coming in here and feeding whichever machine 480. So we'll have two bus ducts running side by side and feeding these equipment. It's coming. That's how we're going to do the bus ducts. Any question? My only concern right now is really understanding that this is the manufacturing floor, and these are all the equipment that you're looking at right in here. Okay, let me see if I can get them side by side. Okay, here you go. Oops, no, we don't want that. There you go. Okay, so all these machines that you look at, the numbers are right in here. Can I have thumbs up, Chad? We got it. Okay, so that's these are all the machines that we need to. I want to remind you guys, Ashley and Tao and everybody else, these are continuous loads. So when we size the overcome detection device stem, what do we do with it? 1.25. When we size the SO cord, what do we do with these amps? 1.25. 1.25 for overcome detection device, 1.25 for the SO cord. Okay, so that's really what the mechanical equipment. Mechanical equipment here, guys, too, is, let me see if we can see them laid out here. Mechanical equipment. Okay, so as we go through the mechanical equipment, I want you guys to see right here. Can you guys see where it says chiller here? All your mechanical equipment are already laid out in CAD for you, in CAD. What I expect you when we start doing Revit, guys, is to import this CAD into Revit. It shows you where the layout of the equipment is, and then you start dropping all these mechanical equipment right at the top of where they should be in CAD and circuit them in Revit. So I want you guys to look at the, oops, here you go. So here's all the mechanical, look at that. Here's also 16 and 15 in hazardous location area. Here's my boiler, and here's all my circulating pumps and PDUs. You talk about PDUs. Here's my computer room. Can you guys see where the computer room? Each one of these square is a rack full of servers that we're going to be working on. Servers. Here's my battery and UPS system is going to be located here. So there's a few things, please, before you start doing, that will be next week most likely. Before we start doing all these wiring, this is your generator electrical room that we're going to put the generator in there, and the electrical room, mechanical room, couple of telephone and electrical room, and there's bathrooms here, and the dock is here, unit heater is here. So please look at all these places before you start doing in Revit. Any question, guys, about this? Any question about this? Okay, so if you get, this is the mechanical equipment, and it will refer us directly into, before we start setting up. I want to go, so this is first floor. If you double click on second floor, again in CAD, we're in CAD. I want to remind you guys, we're in CAD. I showed you the first floor, continue, the first floor. Let's go to the second floor when it loads. Okay, here's what you have in the second floor. In the second floor, when it loads, okay, here you go. We have air handling unit. You guys see where it says air handling unit 1R, 1S, supply and return, supply, return, supply, return. There are 3 air handling units. We'll see, my friend. Supply, 3 air handling units, supply and return. S for supply, R for return. 2 fans coming into the air handling unit. They're located, so air handling unit, Chris, you asked me about where they're located. Here's your air handling unit in the mechanical room in the second floor. Okay, this is the roof here. If you come over here, these are where environmental chambers are, and 2 of them. And these are the benches that we're going to be wiring on the bench. It's a lab, so we're going to be wiring equipment for the lab right in here. And this is where you have a break room, sink and microwave and fridge and so forth. And oh, by the way, there's an elevator here. Later on, I'll give you the size of the pump for this elevator, and a conference room. So this is your second floor. Any question, guys? First floor and the second floor. There's my second floor somewhere here. I'll click on the first one here. There you go. First floor, second floor. Any question about this? Okay, that's in CAD. So please, all of you guys in your team folder, Ashley, you have all the CAD folders for the project, the CAD folder as well as Revit. CAD are only there for reference. Can I have thumbs up that we know that we're not working in CAD and we're just using it for reference? Okay, like we did in the commercial project. I want to open one more time in CAD. I have a roof. There is a roof, guys. So the first floor, second floor, and then the roof. Why do I need the roof? The roof, we're going to be putting a lighting system, and also they have on the roof they have mechanical equipment. Remember what we talked about here? Here's the roof of the building. I want to remind you that first, see where it says exhaust fan number 4 on the roof. So what do you need to do if you have an exhaust fan on the roof? I need to disconnect and I need to power it. So that's why we're going to be using this one too, to put our mechanical equipment there in Revit and circuit them. So I want to remind you, this is where you find them. How about cooling tower? We have a cooling tower. Cooling tower on the roof. We're going to put the cooling tower on the roof. We have also all these mechanical equipment right in here, exhaust one, and I know we're missing one more exhaust one right here. We'll add it as it gets closer. And also on the roof, you will be putting the lightning spikes. We're going to do a lightning control, lightning protection system for the whole building. We're going to be using this view to put the lightning control system. Okay. Any question, guys, about this? Any question? So these are really the 3 files from CAD that you need to pay a lot of attention to. There's panel schedules, not a big deal. We don't use Revit. You need site. Yeah, there's a site too. Site, just to give you a view in the site in CAD. We have everything in Revit to remember. So here's the site. Building, pad mounted transformer. Okay. Is this the right building? opening the different site here. Does that sound like a building sign? No, it is future expansion, yeah. Okay, that should be the right building here. Building and future expansion right next to it. Looks like the canopy, like the commercial project.
Yeah.
Yeah. Let me go to Revit. It's in Revit too. So, okay, site lighting. There you go. No, it's right. It just looks like it. It's a Revit. That's the right one. So here's the site of Revit too. It's the site that we need to do parking lot and so forth. We're going to be working Revit. CAD is only for reference. Only for reference. Okay. Any question, guys? But there's an addition that's not shown in Revit. Future addition that you need to pay attention to. Any comments, guys, about the layout? I know this is hard to see here, but here will be very easy to see how the sign is. Any question, guys, about this? Any question? Do you guys need more information to get up and running with this project? Is that good? Good information to get up and running with it? Okay, so let me download this, and then after lunch, we will do the Revit setup. That's my plan for the day, is to do Revit setup. For the time being, you can go ahead and start your 3 things we're going to do this week. We're going to do load calculation, we're going to do Microsoft project, and we're going to do Revit setup to stay on track. On Revit, I will get back to Revit in a second, guys. So, okay, so that's it.